Hello everybody, this is going to be a quick video over the two major types of balancing. That is random assignment and pre-testing. Now by balancing I'm talking about the tactic of methodological control whereby we try to make sure the groups in each of our individual groups conditions, if we're doing an independent groups design, are equivalent in every way except for the independent variable that we manipulate. Now, random assignment is by far the most prevalent tactic people use to balance. Pre-testing is an alternative, and it's an alternative that tends to be appealing to folks who are new to research methods. But it's not always a method worth the effort, all right? And we're going to talk about that in this video. In fact, it's the principal point of this video. So I'm going to share my screen with you. All right, here we go. So again, we're really going to talk about these two primary methods of balancing, random assignment and pre-testing. Now, again, as I mentioned before, balancing is a method of tactic of methodological control in which we try to take subject variables. These are individual differences. These are characteristics that individuals in our study differ on. So for example, everybody has a different, everybody's not equally pessimistic, not everybody's equally happy, not everybody's equally self-interested, not everybody is the same age, not everybody's the same, has the same culture, and not everybody has the same attitudes on a whole host of domains. So each of these things that individuals differ on, thus individual differences, each of these, if we didn't balance them out, might randomly accumulate in one condition over another. And if that happened, then we would have a confound. We would have an alternative explanation for any change in our DV that's associated with our IV. Because if, let's say, for example, I'm trying to manipulate rejection and see how that affects self-esteem. Well, if I accidentally get all of the people who are pessimistic or the people who already have low self-esteem in the rejection condition, but very few of those in the control condition, then when I measure their self-esteem at the end, it's going to look like the people in the rejection condition have lower self-esteem. But I'm not going to be able to truthfully say that that was my rejection manipulation, or it was simply this individual difference of already having low self-esteem. And so balancing is a method of making sure that the individual differences, the subject variables of the participants in all of my groups, I'm in the example I give you two conditions, a control no rejection condition and an experimental rejection condition. But if I had three conditions, 4, 5, whatever, I want to make sure that the individual differences in my conditions, the individual differences of the participants in my conditions is equivalent. All right, so I want on average them to all have the same self-esteem, pessimism, age, etc. Okay, well, when we do that, when we balance those subject variables, self-esteem, age, pessimism, whatever, they can no longer account for the differences, for any differences between our conditions in our DV. They're no longer an alternative explanation. All right, so how do we go about accomplishing balance? How do we go about making sure that the subject variables between our participants are all roughly equivalent? Well, like I said, there are two main methods. You have random assignment, and this is the dominant method. And then you have pre-testing. All right. Now, random assignment is exactly what it sounds like. You have a sample, and then you randomly assign participants to each condition. Now, this, by random assignment, would make roughly an equivalent number of participants in each condition. All right. And certainly the more participants we have, the more likely that is to happen. So as long as you have a a good-sized sample for your study, random assignment's usually going to do the trick. All right. Pre-testing, on the other hand, is a situation where we test them first, and then we assign people with roughly the same qualities to each of our conditions, each of our experimental conditions. Now, we also use pre-testing to match people to make sure that, so sometimes I have students who are learning this for the first time or who are new to research methods. They'll say something to the effect of, well, don't you need to measure your DV, measure them on the DV first so that you know that your IV has done something? Well, no, actually we don't. All right. If we're randomly assigning, then if they were going to do well on the DV before, then there's an equivalent number of people who would have already done well in both conditions. If they were going to do poorly on the DV in the first place, then there's an equivalent number of people in both conditions. So if you randomly assign, no, you don't need to measure them on the DV first. And depending upon how you measure them on the DV first, it could bias or alter the responses they give on your DV when you measure it for real. All right. So, which do we do? Do we randomly assign? Do we pretest? Let's talk really quickly about random assignment. Well, as I've already said, random assignment, as long, oh, I misspelled something. Hold on. Oops. All right. With random assignment, as long as you have a large sample, then your study is going to, random assignment is going to properly balance your study. Now, can random assignment fail? Absolutely. All right. And it becomes more and more likely to fail as your sample gets smaller and smaller. But if you have a large sample, all right, then the chances of you getting more participants with one kind of subject variable in one condition than the other drops. All right. If your as your sample size gets bigger, chances of you getting a disproportionate number of people with a certain individual difference in one condition drops. All right. So either we have a large sample size or we replicate multiple times, okay, with different people. But by virtue of replicating with different people, we're increasing sample size across study. So random assignment can usually do the job of balancing individual differences in subject variables, provided we have enough participants. It balances those subject variables. Simply by random chance, you're going to get roughly an equivalent number of people with every subject variable in both conditions. All right. Now, is it going to be perfect? Is it going to be exactly equivalent? No. But are you going to always be able to make things exactly equivalent using pre-test testing? Well, potentially, yeah, you could, potentially. But at what cost? So let's talk about pre-testing. What does a pre-test do? Well, it can ensure balanced groups. You can verify, you can make certain that your two groups are balanced on all variables other than your IV. All right. So we should pretest, right? I mean, every study should pretest, right? Well, hold on. Not necessarily, because pretests come with a lot of costs. And these costs can sometimes, in fact, many times, outweigh the benefits. All right. So much so, in fact, that on average, if you have a choice between pretesting and random assignment, if you have a good enough sample size, then my recommendation to you is don't pretest, randomly assign. Okay. But let's talk about, and certainly if the costs of pretesting outweigh the benefits, don't pretest. All right. So if the costs outweigh the benefit, if the costs of pretesting outweigh the benefits of pretesting, don't pretest. All right. And there are quite a number of costs to pretesting. For example, first, conversational norms. All right, there's a whole slew of conversational norms, and you know these conversational norms implicitly because when people violate them, it seems weird to you. So, for example, if I asked you, "How are you doing today?" and then you told me, and then 2 seconds later I said, "So, are you having a good day?" I just told you I did, that I am or that I'm not. That's redundancy. All right. So what's going to happen if you ask people the same question multiple times is they're going to react much the same way I just portrayed there. They're going to do their best to give you the exact same answer they gave you the first time. All right. And so certainly with survey research, if you tried to pre-test with a survey and then gave them gave some people the experimental condition and some people the control condition, and then measure the DV again, chances are you're not going to find an effect. And the reason for that is because what they answer the second time is probably going to be pretty close, if not identical, to what they answered the first time. Okay. Even if you gave a dissimilar measure in which you messed it up a bit, so they can't give you the exact same answer, chances are they're going to give you a conceptually similar answer. All right. They're going to give you an answer that means roughly the same thing. All right. Now, yes, you can fix this by separating your pretest from your DV measure significantly. And you won't be able to do that in a single research session because that would make it too long. But you would have to make the 2 times distant enough such that the participant doesn't really either remember what they answered the first time, or they think to themselves, well, it's possible that it could have changed. All right. But either way, that's not something you can do in one study. All right. Yes, there are potentially ways that you could make them believe that it could change, but very frequently, just measuring it first, giving your experimental or control condition, and then measuring it again won't do the trick. You'll get that conversational norm of redundancy. So you get the cost of reducing the sensitivity of your DV. You get the cost of making your DV seem unchanged by your IB. Another cost is attrition. The more measures you put in a study, the longer you make that study. The longer you make a study, the more likely it is that some people are going to drop out. All right. And especially when a study is long, if participants start seeing redundancy, so this kind of compounds with the first one, if a study is long and it's redundant, participants will start skipping whole sections. So, they might complete your pretest, do your experimental condition or control condition, and then if they're already 30 minutes in, if you give them the same measure again that they did at the first of the study, chances are they may not even answer it, or they'll skip a lot of items. All right. So these costs can compound upon one another. Also, if you pre-test someone and then give them a post-test in the same experimental session, chances are you're going to give the participant expectations about what you're looking for. And participants usually do one of 2 things when they get an idea of what we're wanting. They either try to be really accommodating and give us what we want, or they try to react and they try to give us the exact opposite of what they think we want. Either way, they're altering their response. They're changing the way they would react. And so your DV is no longer capturing the real behavior. All right. So for all these reasons, doing a pretest in the same experimental session as a post-test, as the DV measure, is a bad idea. All right. In all of these ways, doing a pretest, using pretest to balance in the same experimental session can cause problems. Now, when might we use pilot or pretesting then? If there's a whole lot of cost but very few benefits, really only one, then why would we ever use it? Well, there are a couple situations. First, sometimes we don't have access to a big enough sample. Sometimes our sample is just small and there's nothing we can do about it. In that situation, and we're only ever going to have a small sample, in that situation, that using pre-testing to match participants may be effective, all right? Because now the benefit of pre-testing becomes pretty powerful because there's no other way to do it. There's no other way to balance our participants. Another time when we might use pre-testing is when it can be more beneficial than usual. So for example, if we could use pre-testing to offset participant attrition. So, you know, sometimes participants will, in one condition, may quit at a higher rate than participants in another condition, right? It's possible that participants in one condition might quit. Maybe there's something about the experimental manipulation that just makes it harder for them to deal with. They don't want to deal with it, makes them bored. I don't know. All right. Sometimes there are things in one condition that make people more likely to quit, therefore the attrition rate to be high than in the other condition. Well, sometimes we can use pre-testing to identify the types of folks that are likely to quit and then remove them from both conditions. So we're matching, all right? And so we remove attrition. Another time, sometimes we can use pre-testing as a post-hoc way to match. So let's say, you know, you didn't anticipate that a lot of participants would drop out of one condition but stay in the other. Well, if you've got some information about the participants, you can find if there's any pattern to the characteristics of the people who quit from one condition, identify participants in the other condition with similar qualities and remove them such that your two conditions are matched again so that they have the same, on average, the same qualities. So in those instances, the benefits of pre-testing go up. And so the argument for using pre-testing becomes stronger. Sometimes we can also significantly reduce the cost, you know, so conversational norms are a problem certainly with survey research, but other measures don't necessarily have conversational norms to worry about. So for example, physiological measures, reaction time measures, but pre-tests in these can also potentially influence the subsequent measures. So for example, let's say I'm giving you a physiological measure, right? And so I want to measure your baseline anxiety. Well, if the participant catches on, if that's what you're doing, that you're measuring their anxiety, and then they won't necessarily do that. But if they catch on, then that might lead them to do things which would alter their physiological anxiety the second time around. With reaction time test, which is a test that uses a behavior that requires participants to react as quickly as they can. If you have them do a pre-test, then the second time around, their responses are going to be slightly different because they've probably gotten a little bit better after doing that pre-test. And so some of the responses may differ. So if you can limit these, and certainly then in these situations, doing a pre-post test in the same experimental condition isn't necessarily as detrimental, so you've reduced the costs. So there you go. Not enough people for random assignment to work. You can use pre-testing is justified. There's pretty good evidence or pretty strong expectation of subject attrition from one of your conditions. Maybe we want to use some pre-testing. Or pre-testing probably has reduced costs because it's very hard for it to affect their subsequent responses. Then pre-testing might be the way to go. So what do we do? What do we do? What to do? What to do? Well, pretty simply, as long as you have access to a large sample, randomly assign. That's going to do the trick. That's going to do the trick more times than not. And it's very cost efficient. All right. Pre-testing requires has a lot of costs for the things mentioned. Just go back to the things we talked about. But it also costs time to the participant. It costs potentially, if you're, let's say you're collecting participants on MTurk, Mechanical Turk or Turk Prime or one of these services, because you're pre-testing, your survey is longer, and so you're having to pay participants more. So it may actually cost you money. All right. So if you have access to a large enough sample, randomly assign, because it's pretty simple to do. All you do is make sure that people are randomly allocated to which condition. No time is required in doing that nowadays with the technology we have, all right, or at least very little time, all right. Now, let's go back to that question that I mentioned a couple times. Don't I want to know how participants do on the DV before I manipulate my IV? Well, no, not necessarily. That usually what we're doing is we're trying to ascribe causality to the experimental variable. Well, random assignment balances people out on everything, including their original status on the DV. So if you have a big enough sample, you don't need to know what they would have scored first, because what they would have scored first will be balanced out by random assignment. All right. All right, guys. The last thing I'll mention is that everything we've talked about in this video is focused largely on independent groups designs. With repeated measures designs or within groups designs, you get around this really, because every participant participates in every condition. And so you can kind of think of it like you're essentially pre-testing, because you're testing each participant in each condition. But these designs have their own issues, which we'll talk about in a later video. All right, guys, that is it for this video about types of balancing. As always, if you have any questions, let me know. If not, I hope you find this video useful. And if you have any questions, send them my way. If not, I'll see you all later on.